Hello everybody, this is Itsu again. I got some reactions on my Capcoil 2 video. User YBigness5 had some questions, so I'm trying to find some answers for him. I hooked up my Capcoil again. It's attached to two 12 volt batteries in series, so 24-25 volts. I hooked up some decoupling ceramic capacitors over there because I have a lot of RF noise also there, and I have hooked up the green wire is ground going to the minus of this battery. I've taken my Capcoil again. It's a 40 microfarad capacitor, a motor run or a motor start capacitor, and it's about 25-30 turns wrapped around it. I'm using a AV plug construction 2x1N4007 diodes and I have hooked my Fluke multimeter across it. What I did is I have inside this Capcoil I have this copper pipe with a slit. It's a kind of pickup, RF pickup, and it goes all the way down and comes out to the back. So I have here a high voltage lead and I've attached it to one side of the coil. And I will now hook up the cache, and then we will see what is going to happen. Yesterday, without connecting the high voltage leads, so only the open end on the coil, it went to a nice voltage, but this way it goes much faster, as user YBigness predicted. So I'm going to attach the cache now. You can see it's climbing 200 volt, 200. I will stop now at 300 or something, because otherwise I'm not sure what my capacitor will do. So in a few seconds it went to 311 volts, and I don't think there is a bleeder resistor inside the capacitor, so it's going to decrease now a little bit via the voltmeter, the multimeter, I think. So this experiment is very good. It's loading this Capcoil very fast, I think. I have a bulb here and I can discharge the coil. Let me see if I can do that with one hand. Yes, there it was. So we have some capacitance there, voltage. I also tried this microwave oven capacitor. It's a 1.2 microfarad. It has a internal bleeder resistor, 10 megaohm. And I hooked up a AV plug construction with two ultra fast diodes U860s, but with this combination I only get 60 volt maximum. So there's a big difference, probably because of the internal resistance. Okay, this is the first part of this little test. Thank you for now. Okay, welcome back. This is Itsu again. Another question I got is what will happen when I hook up the coil, which is wrapped around the Capcoil, directly to the capacitor. So I have connected the first lead to the bottom lug of the capacitor, and I attach the other via a crocodile lead to the top, and I still have the AV plug and the Fluke meter hooked up, but I basically created now a shortcut across the capacitor. So when I now hook up the cache, like now, you will see nothing is happening. There's no build-up of voltage because there is no the shorting is because of the coil across the cap, so this is not going to work. Okay, this is Itsu. Welcome back again. Still working on my Capcoil configuration. I have another motor start capacitor, 30 microfarad, and I wound another coil, but I'm now using magnet wire, AWG 24 or something. So I have much more turns around the capacitor. Again, I have the AV plug going to ground, and I have my flux meter hooked up across the capacitor. One side of the coil is connected to my cashier coil, the middle pickup copper tubes with the slit coming back, and then I can attach the high voltage, high frequency voltage to anything I like. I also hooked up a voltage divider to ground, and I have hooked up my red probe across the lowest resistor, so we can have a look at what signal it's coming from, but it's normal resonance sine wave of about 1.3 megahertz. But you will see that the voltage is climbing very rapid, so I have to shut it off in 3 or 4 seconds, otherwise it will exceed the capacitance of this capacitor, the voltage rating. Again, using my double batteries, 12 volts in series, 25 volt, I'm running about 1 amp, so input of the whole cashier coil is about 25 watt. Okay, so I'm trying to focus now on both the voltage meter for reading the voltage, and you can see the, I hope, the voltage sine wave from the probe. There we go. So the voltage is climbing very rapidly, 200 volts, 300 volts, and we have 1 point something frequency. So I now have to stop because otherwise I exceed the ratings of my capacitor, which is 550 volts. So you can see that again this AC RF is filling the cap quite fast. I want to make some other tests like JBigNess 5 proposed, but it includes some spark gaps or some discharge lighting arresters, but I only have the ones of 600 volts, but these are too high for my capacitors I'm using. So I'm waiting for some 250 and 300 volt lighting arresters I've ordered, and perhaps I can then make this this loop back from the coil to the capacitor with a lighting arrestor in between, and see what's happening there. Okay, thank you for watching. Okay, my next test, I have the same capacitor of just a few minutes ago with the AWG magnet wire, but now I have connected it back to the both capacitor terminals. So we have now a capacitor and a coil hooked up together. But as this is a short cut for the capacitor, nothing happens when I put it nearby the RF of the cache. Then I wound another coil around this Capcoil combination I had. So this is a coil wound around the magnet wire coil that's underneath it. And then I would like to put in there the high voltage, so I have an inductance combination to the first coil, which is connected to the capacitor terminals. But also this combination is not working. I've hooked up my flux meter, and I will now connect the cache, and you can see that I have some very reaction, but nothing is climbing, no voltage coming up. And that's logical because we have a shortcut of the coil to the capacitor. And there is no tank circuit building up which can create a resonance to this combination. So I have to go for the next step, which is to insert a lighting arrestor or a spark gap in between, so that we can first fill up the cap in this combination, and then let it short it out when it's certain voltage is reached, like 200 or 300 volt, and then see what's going to happen inside this combination. Okay, that was it for now. Thank you. So this is basically the last schematic I had in the last video. I have my capacitor. There is a coil around it with the magnet wire. Attached to the lux, I have the voltmeter across the lux, and I have the IV plug to ground, and I have the second coil around the first coil here, and then I have the HF voltage inductively coupled to this combination. But as you could see, there's no voltage building up in this situation. So the next thing I will do is to include a spark cap here or there, and see if it can build up a voltage first, and then when it discharged, to see what happened in this situation. Okay, thank you.